Encryption and key management are not the same thing, and not all encryption is created equal. In this demo, we'll try to show how that even by having the highest levels of key management control, it may not be enough to protect the security and access to your most critical data stored at rest inside an EBS volume, and how Thales CipherTrust transparent encryption, by way of bringing your own encryption, is able to improve the security and access to your data while also helping you achieve full data sovereignty. At the center of my taskbar, I have three different Chrome windows. In the first window, I am logged in as root under my victim account. And in the US East 1 region, I have this critical EC2 workload instance that is stopped at the moment. Under the storage tab, we can see that it has 5 additional 5 gigs EBS volumes attached to it, with each volume containing a single piece of critical information. Notice that 4 of the 5 volumes have been encrypted, with each volume encrypted using a different key type, while the 5th volume is left unencrypted. Now I'm going to try and start the instance as root, which as soon as I click start instance, we get this notification that the instance has successfully started. However, if we try to refresh a few more times, we'll notice the instance never actually starts and remains in a stop state. Now, if I try to switch over to the second Chrome window where I'm logged in as Crypto Carol under the same AWS account and region, which has the same instance, if I now try to start it, we get the same notification, but now if we refresh, we see the instance is now in a pending state, and if we refresh again, the instance is now running. The reason is because user Carol has met the conditions defined by the key policies, which follow least privilege for each of the different key types. Now that the instance is up and running, let's try to SSH into the instance. We'll start by running the command lsblk to show us the volumes attached and the mount points. If we try to list the directories inside /data, we can see the 5 directories for each of the volumes based on the different data classification storage class. Now, if I try to list all the files inside these directories, we can see that we have a single file or flag stored under each directory. And based on the names, anything under confidential will be protected using a BYOK. Anything under internal will be protected using a customer managed key. Anything under private will be protected using an AWS managed key. This public directory is unencrypted but has a file, and anything under restricted will be protected using a key stored outside the cloud provider's control. Now, if I try to read all these files at once, regardless of the key management option used to encrypt each of the different volumes, as a privileged user, I'm able to read all the files except for one. That's because that file, while stored under an unencrypted volume, it is protected using Thales CipherTrust transparent encryption. To confirm, I'm going to switch over to my third Chrome window where I'm logged into my CipherTrust Manager console, and under that transparent encryption tile, I can see that I have a healthy agent running and registered with the appliance, which is the agent running on our EC2 instance. If I select the hostname, we can see under the guard point tab that we have a directory the agent is protecting. However, the encryption and the access controls to this directory are currently disabled. If I try to re-enable the guard point, switch back to my PuTTY terminal, and try to read all the files again, I'm able to read the same files as before, but now I'm also able to read the context inside the CTE-flag file. Now let's go back to our CipherTrust Cloud Key Manager console and filter down to our victim account. Let's look at only the US 1 region and only look at my EBS keys. Here are the 4 keys that are being used to encrypt each EBS volume. This first key at the bottom is an AWS managed key. The key above it is a customer managed key. This is a bring your own key, and then we have a hold your own key. Now what happens if I disable the key? The instance is still running, and I'm still able to read all the data. Now, what if I delete the key material? Same thing. Instance is still running, and I'm still able to read all the data. Now, what if you try to block the connection between our CipherTrust Cloud Key Manager and AWS XKS? Nothing. The instance is still running, and we can still read all the data. Now let's try to disable our CTE policy again. Now, while the instance is still up and running, the data is no longer accessible. That's because CTE is providing a file level encryption solution, while all the other cloud key management options are simply doing disk level encryption. While each encryption and key management option provides different benefits and values, it is important to understand your environment and the risks you're trying to mitigate or reduce in order to choose and apply the right set of data security controls.